Again, back in my house. We're going to continue with our notes on the immune system. We're up to the third line of defense, and this is the really specific reaction of your body to a very particular invader. It's called the third line of defense, or your immune system. All right, so if an invader does begin to successfully reproduce in your body, it makes it past the first two lines of defense. Different white blood cells, WBCs, begin to attack. First, the macrophages. Now, wait a minute. We heard about the macrophages already in the second line of defense. Well, it turns out they're important now also. They're the big eaters. They're the vacuum cleaners that come by and eat everything. The first thing that's going to happen is the macrophage is going to eat an invader. In the cartoon that we have here, you see viruses that are getting eaten, and they have these little arrows on them. Those arrows represent the foreign proteins, the antigens on the surface. So that macrophage is actually going to carry one of those antigens, and it's going to go look for a helper T cell that has a matching antigen receptor. It's looking for a very specific helper T cell. So we'll get to that. All right, so the macrophages call in the helper T cells. Now, I say AKA the generals. I have this war analogy that I really like to use when trying to teach the immune system. So in my war analogy, the macrophages are like a king or queen, and they realize that their kingdom is being invaded. So they take their foreign antigen and they hold it up to their helper T cells. And the helper T cells are like generals in a war. Generals don't do combat. They don't shoot missiles or drop bombs or do hand-to-hand combat. Generals are there to boss everybody else around, to boss the other soldiers around. So in my war analogy, the helper T cells, they don't fight. They tell the other cells what to do. So those are the generals. So once the generals have been told that there's an invader and which invader it is, the helper T cells then go to the other white blood cells and tell them to attack. Now there's two kinds of attacks. The first one is the TC cells. The helper T cells tell the TC cells, which stands for T cytotoxic or cytotoxic T cells. He tells them, the general tells them to poke holes in virus-infected cells. So imagine you have this kingdom that's been invaded by bad guys, and some of the bad guys are hanging out in the houses of the kingdoms. You need soldiers who will go into those houses and attack the bad guys that are in those houses. So that's what these cytotoxic T cells are. They're soldiers that are involved in hand-to-hand combat. But there's also going to be, in a war, at least a modern day war, there's going to be long-range artillery, missiles, bullets, that kind of thing. So the helper T cells, those generals, are also going to pull into action another kind of cell called the B cells. The B cells are the ones that are long-range artillery. They're going to shoot bullets or missiles. And those bullets or missiles are like heat-seeking devices that look for the bad guys, that look for the invaders. Those bullets are called antibodies. So the B cells send antibodies, which look like little purple Ys in this diagram, to attach onto the bacteria and viruses. And once the bacteria and viruses get covered with antibodies, they're harmless. They can't hurt you anymore. And actually a macrophage comes by and eats them. So in our war analogy, imagine that some of the bad guys are gathering in the streets of the kingdom. So these heat-seeking missiles or these bullets are going to attack these bad guys that are in the streets of the kingdom. Okay, so the antibodies are proteins that stick to the invaders and paralyze them. Next, what are the big eaters really called? Those are the macrophages. I'm going to have to go through these quickly so we don't spend too much time. Cast of characters, the enemy invader. Just pause this if you need to. The enemy invader would be a pathogen, so bacteria or virus. The king is the macrophage. The general is the helper T cell. The combat soldier are the cytotoxic T cells, also called TC cells. The artillery are the B cells, and then the bullets would be the antibodies. All right. Once you've fought off a disease, then you then have a special kind of B cell that are called memory cells. And the memory cells patrol the body from then on, looking for that same invader. If that same invader, now this is going to fool you for a minute, but if that same invader ever comes back, the memory T cells cover with antibodies right away so fast that you don't ever get sick from it again. You don't notice that you ever came down with it a second time. So most people are sitting there going, KJ, I come down with a cold like 6 times a year. Are you really telling me that I don't come down with the same thing? Well, kind of, sort of. The idea is that, the theory is that every time you come down with a common cold, you've actually come down with a mutation of the common cold. And so it's actually slightly different than the one that the memory cells from your last cold are looking for. And so every time it shifts, you have to fight them off again. But if it's ever the exact same common cold, your body fights it off and you never even know you came down with it a second time. All right, moving on. Let's talk about a couple things that are malfunctions of the immune system. The first one is allergies. Allergies is when the immune system has an abnormal response to harmless environmental antigens. Remember, an antigen is a foreign protein. So harmless environmental antigens would be things like pollen, when the immune system overreacts because of pollen. Now, students often ask me, why does the immune system do that? I can't go into details here because it's pretty complicated stuff. You'll just have to trust me that, for example, some people in their nasal passages have receptors, and I'm making a shape like this on purpose. They have receptors for certain pollen molecules. And so when pollen gets into their nasal passages, it lands on these receptors. And then as that person breathes, that pollen cell goes deeper back in their nasal passage, and it brings the receptor with them and rips open the cell that was in their nasal passage. What that does is it releases histamine. Remember from our second line of defense, histamine increases blood flow. So that causes an increase of blood flow to the nasal passages. So people might get red, swollen, itchy eyes. Their nose might feel puffy and start to run. They might get an itchy throat. That's all because of that release of histamine. And that's why antihistamines are effective treatments for somebody who's having an allergic reaction. All right, another example of the immune system malfunctioning is called an autoimmune disease. The prefix auto means self. So when you have an autoimmune disease, it means the immune system is attacking yourself. This is when the immune system, certain immune cells are born that have receptors for your own proteins. So they see your proteins as foreign proteins. They see your proteins as antigens. And it happens to very specific tissues in the body. So there's different kinds of autoimmune diseases. So for example, the picture shows rheumatoid arthritis. In that circumstance, the immune system is attacking the tissues of the joints. And it's not just in the hands. It can be in the spine or the knees or the hips, any joints. I'm going to have to let my dog out while she's barking. Sorry about that. All right. Other autoimmune diseases include lupus, Graves' disease, and multiple sclerosis. MS is when the immune system attacks the myelin sheath. It's the protective coating on our nerve cells, and it causes the nerve cells to short out. And so people with MS get varying degrees of weakness. And some people have it very mildly, and some people end up in wheelchairs. So autoimmune diseases can have flare-ups where they're really bad, and other times where they're under control and not as noticeable. All right, what's a vaccine? We've talked about vaccines once before, so I'm just going to say this quickly. Again, a vaccine is an injection of a weakened antigen or a weakened protein. It allows the immune system to learn to recognize the disease without having to fight it off. B cells or memory B cells get formed that patrol the body then for the rest of your life. They can rapidly release antibodies and stop the disease if it is ever encountered naturally. Well, okay, we'll go with that. So B cells are supposed to be, the memory cells are supposed to be there. This ties into the next slide, which is about active and passive immunity. Active immunity is when your body fights off a disease itself and forms its own memory cells. So vaccines, if you had to choose, this is definitely a test question, by the way, if you had to choose between the terms active and passive immunity, it seems like vaccines would be passive immunity, but they actually give you active immunity because they're really injecting the disease into you. It's just a weak form of the disease, so your body fights it off, you develop memory cells, and you have those memory cells for the rest of your life. The only circumstance really that we come in contact with passive immunity is, interestingly enough, is breast milk from women. Breast milk transfers the woman's antibodies to the baby that is drinking the breast milk. And what that does is provides the baby with protection from any diseases that the woman has come in contact with for approximately 6 weeks until 6 weeks after breastfeeding has ended. So doctors really, really encourage women to breastfeed to help boost their children's immune systems because babies have very, very weak immune systems. After 6 weeks, that immunity goes away, and then the baby is on their own to produce their own memory cells and their own antibodies. All right, ladies and gentlemen, it looks like that's it. Let me know if you have any questions. Have a great day.